Okay, so I'm going to talk briefly about two standards, OpenHAN and Green Button, and their role in demand response. My role is the Chief Regulatory Officer for Global Smart Grid Solutions for Siemens, working through eMeter, which is a software company that Siemens purchased recently and is now part of the Smart Grid division within Siemens. So I do a lot of work in North America as well as in Europe on various regulatory policy issues, including standards. As we think about standards, I always like to start at the beginning, which is what are we all trying to accomplish as an industry, and this slide gets to that. So why the smart grid? What's good about the smart grid? So when we look at some of the key benefits of the smart grid, first is reliability. So reducing the number of outages and lengthening or shortening them, reducing the length of the outages, I was trying to say. So adding automated sensing and control to the grid to do that. The second thing is financial savings, which everybody's interested in, by improving the load factors through reducing peak demand, and other system efficiencies like reducing line losses or managing voltage more precisely. A third area is promoting renewable energy. Europe, of course, has the 20% goal of renewable energy by 2020. Electric vehicles reduce carbon emissions, and so that's another policy goal that the smart grid promotes. And then finally, an empowered demand side. And that includes both on the regulatory side, having business rules and regulations that enable the demand side to participate effectively in the electricity market, as well as technology. And to empower the demand side, I talk about a consumer empowerment triad. Just three things will enable energy users to participate in the maximum fashion in managing their energy and achieving some of these goals. So the first is usage information. That enables energy users to understand how they're using energy, what is using the most energy, where they should be focusing, and how they can actually affect their usage. This could be real-time. This could be analyzed information. For a commercial customer, it might be comparing facilities, things like that. Second is pricing options, so that customers can actually save money by shifting load off-peak or take advantage of low off-peak prices, for example, to charge electric vehicles. Right now, very few customers have time-based pricing, so there's really no point in shifting consumption. And then the third is automation, so that they don't have to think about this all the time. And nobody wants to think about their energy usage. They would like to be able to save money and promote a better environment, but without having to think about it all the time. So things like smart thermostats or smart building controls come into play there. If we look at the business case for the smart grid, the goal is to enable that demand to empower energy users through a combination of market mechanisms as well as technology. So that includes metering, it includes software, it includes communications, and it enables this intelligent energy efficiency based on information. What's the business case? Is there a business case for this? And one thing you'll hear us talk about is very large savings available from demand response programs. This is just one example from the UK in looking at the rollout of their smart meters. Over the period of the project, they get total benefits of about 18 billion pounds versus total costs of around 11 billion pounds. So there's a large net benefit there. If you look at the chart on the right, you see on the right side of that pie chart, the light blue and the dark blue are the demand side. So the light blue is intelligent energy efficiency, that's understanding usage better. and the dark blue is load shifting, and you can see that makes up about half of the benefit case in the UK. That, of course, varies by country or by state, but it's sufficient to say that the demand side is a huge part of the benefits case. Are consumers interested in these things? From 40 to 80% are interested in time-based pricing and more energy usage information. There's similar polls on automation. Now, getting to the standards, quickly, this slide illustrates really two standards that go right to the heart of what I was talking about to achieving those benefits. On the bottom, there's a meter that interfaces with a home, in this case, a commercial building is the same, through this home area network HAN radio. So that interface is a critical standard because whatever that interface is into the premise will enable, as a standard, will enable market producers to produce devices, in-home displays or gateways or home energy management systems or building energy management systems that can then communicate with the meter. So that's critical to enable that market. The second one is the interface to providing information. And this slide is showing two legs of that. At the top showing the OpenHAN interface, which stands for Automated Data Exchange, Automated Data, or Automated Demand Response. So that's really two standards for sharing information with authorized third parties that can help consumers and energy users manage their energy or reduce their peak demand. And then there's a subset of that, which is the green button standard for downloading energy information to by the customer directly, and which they can then use themselves or provide to a third party to help them manage their energy usage. So that's just a quick introduction. Wanted to highlight those things, and we can come back to those if there are any questions or follow-up subsequent to the webinar. So with that, I'm going to turn it over to Thomas to carry on.
Okay, welcome everybody. My name is Thomas Schaub. I'm at Landis+Gyr, responsible for standards and interoperability. And let me see. Can you see this the screen now? Is it okay?
Yes.
Okay, good. Yeah. Okay, and I'll entertain you in the next 10 minutes with interoperable devices. Are they reserved for giant utilities? And I will address, on the one hand side, the standards, and on the other hand, the purpose of the standards, interoperability, and what can be achieved or not. Let me start with two myths and facts. The first is that people think, or politicians think, or hope that if they mandate for standards that they will get interoperability. Well, reality is a little bit different. It's more bitter than that. In order to achieve interoperability, standards are a first step, but they are by no means sufficient. So if standards would be sufficient to achieve interoperability, then we would live in an interoperable world, because we have lots of standards. There is no lack of standards, but there is nearly in the field, in the domain of smart metering or smart grid, there is nearly no achieved interoperability. And that brings me to the second myth, that interoperability is interpretable. If you look at all the slides which are presented, and if you compare it to reality, then I think it is obvious that most of the people interpret interoperability in a different way. Now our experience is that when it comes to smart meters, and we see smart meters as part of the smart grid, and if you speak about smart grid, I guess today the smart metering applications are the only domain where we have at least some kind of experience. The rest is more visions and will be hopefully reality in the future. So if you look at smart metering, I think there is no way to interpret interoperability. For the mass deployed devices, our customers, for the high volume devices, our customers simply expect interchangeability when they speak of interoperable meters. What they mean by interoperable meters is very simple. They want to be in the same situation as they were 10 years ago when they have the very stupid meters where they can buy meters from any manufacturers and just replace it and interchange it between different manufacturers. And that's really what they also want when they speak about high smart meters. On the system side, this could be a little bit different, but for the high volume device, it clearly means interchangeability. Now, sometimes it's good to look a little bit back and see what has been achieved, to have a look, to look at reality. And if you look at where interoperability has been really proven in smart metering projects in Europe, then I think we just have 2 projects where this has been the case. By the way, do you see this control thing of the webinar always on my slides, or do I only see that on my slides?
You should see it only on your own, Thomas.
Oh, okay, good.
Yeah.
Good. Then it's fine. Okay, then one of these projects is certainly this ERDF project, the Linky project, where 300,000 PLC meters have been deployed, 7,000 concentrators and system, and even the devices are from different manufacturers. And I can assure you that ERDF made sure that the equipment which was deployed was really or is interchangeable, that you can use one meter from one manufacturer and replace it by a meter of another manufacturer. Here I list the different participants or the manufacturers, not to promote these, but just to show that it means really interoperability between different manufacturers on all levels, not just on the meter level. And then we have another project for smart metering, that's the Iberdrola project, this famous PRIME project, where I guess in between are about 200,000 meters in the field. Also there, several manufacturers on all device levels, and also they achieved interoperability in the sense of that you could exchange the meters. Now, what's the learning of that? The learning is that interoperability can be achieved, but it can be achieved between several manufacturers, so you could exchange devices between several manufacturers, but in both of these projects it was only for one single giant utility. And if you look at what has been achieved on reality, it looks like interoperability or exchangeability can only be achieved for giant utilities. Now let's step back a little bit and see what is the formula for success. Why could they achieve that? And I guess the critical part is, if you speak about interoperability, one party must take the responsibility from the specification to the testing. It's a different thing of writing a standard where the outcome is just a document which has no practical effect. When we speak about interoperability, we don't speak about documents, we speak about products, and either they are interoperable or they are not. So if you look at the giant utilities, they have achieved that. What they have achieved is they have achieved that several manufacturers support one utility-specific solution. And now several manufacturers have come together and formed this IDIS association, where we want to show that interoperability can not only be achieved for giant utilities, but also for other utilities. And the big difference between what the giant utilities did and what the IDIS association did, we also provide interoperability between several manufacturers, but also we want to be utility independent. So practically speaking, if you look at the achievements in France and in Spain, Prime and Linky, what the ERDF achieved is a specific optimized meter which is optimized for the needs of the ERDF. Spain, the same thing, a meter which is optimized, customized for Iberdrola. And what we want to achieve with IDIS is we use the same standards, we base the communication on the same standards, but we want to provide a meter which can be used by different utilities. Of course, as time goes by, we will also provide new, integrate new communication technologies. Prime is a candidate, and in later maybe also G3. What is now the organization of this IDIS association? The IDIS association wants to provide interoperability based on existing standards. So IDIS will not invent new standards and not change the existing standards. All what we do, we use standard agreements, standards, and write out of that the interoperability specification. Because in a standard, because the standard is always the result of a consensus finding process, and therefore in the standards you have to build in many options, and many things are still left open, and those gaps have to be filled by this interoperability specification. That's the work then of this IDIS association. With these specifications, the utilities will use it or use them, and they put it as part of their tenders. Then the manufacturers can also have, all the manufacturers have access to these specifications. They produce the equipment according to this specification, but with that you are not finished, because you have to provide also the testing part. So the IDIS association develops test tools according to the specifications, but in order to keep independency, we have made a contract with the famous test institute that the manufacturers can do their testing on neutral grounds. So the testing is done at KEMA, and the manufacturers can bring their devices for testing, and KEMA will provide a test report. With this test, and these two things are completely independent, so the IDIS association is not aware of who is testing and how good the tests are and how many times he has to go to the testing. When he has the final test report, he goes to the IDIS association, the manufacturer, with the test report and his device, and he will be granted the IDIS test label. And every IDIS test label has an individual number, and on the IDIS association website there is a list of all the tested equipment and all the test reports showing all the test results are open to the public. So it's all transparent. You will see all the features of the devices, and you will see all the tests fulfilled. Yes, that's about the process and the association. I think at the moment IDIS is the only association in this field which provides such a service. And what others say about IDIS, I think we have this Pike research report who did a summary on the IDIS association. I think they said it in very nice words. They said this is for small and medium-sized utilities who don't want to go through all the trouble of writing their own specifications and providing their own test equipment. So it's really taking the burden from those utilities who don't want to do it. It's not a competition. It's not competition to the giant utilities or the big utilities who can afford to do everything by themselves. It's just a possibility that the medium and small-sized utilities or the big utilities who don't want to do that or cannot do that, that they have a different means to do that. Okay, that concludes my talk. If you want to know more, if you want to see all these test reports in all the details, it's open to everybody. Go to the IDIS Association website and you can download everything. Thank you, everybody.
Okay, thank you, Thomas, for that introduction. My name is David Main. I'm with Digi International, and I'm going to be discussing briefly the Cloud Serviced Enhanced Interoperability. We have a number of standards groups. We have a number of initiatives to drive interoperability. I want to highlight a couple of the experiences that device connectivity solutions have enabled to enhance interoperability between devices. Digi, as a company, is a device connectivity solutions provider, and as was mentioned at the beginning of this webinar, there are a broad range of services, from demand response to energy efficiency to prepayment services, and it all moves around what many refer to as the extended grid, or all these devices beyond the meter. And there are two ways to drive standards, or to drive interoperability. One is through standards. This is an industry group driving specifications. It's a lot of what we've talked about. An example might be the PC. There are personal computing devices, and they're basically many different manufacturers that can come together to create a system that operates. There's also manufacturer-architected solutions, and this is one company providing all components of a delivered solution, like Apple. Both can work, and they can drive interoperability, but if you want to gain broad industry adoption, you're going to have to drive standards. And as was pointed out by Thomas in the previous presentation, standards are a baseline, but they do not ensure interoperability. So, standards equal interoperability, but what about standards evolving, moving from a smart energy 1.1 to 2.0 or any other standard features? What about extended features of the devices, or provisioning of the devices, or configuration? All these life cycle management features need to be considered. And this is where a cloud-based service can really enable future growth. The ultimate goal of any of these initiatives within SEDC is to have any device connect with any application. And this is really all devices, again, beyond the meter, beyond what the utility has typically operated with, and the focus is around life cycle management. You need to be secure, you need to be scalable, it needs to be an open architecture, and there needs to be a lot of cooperation between the device manufacturers. Again, in looking at this, when you architect a cloud solution, you need to focus on cooperation between the device manufacturers. You have to have a standards baseline, but you have to have an interop lab and cooperation where the device manufacturers work together, as was pointed out previously, to ensure interoperability. And then the cloud service really provides the provisioning, the device driver downloads, and subscription to a variety of applications, whether it be demand response or energy efficiency or meter data collection. All of these need to be subscription services that build around a cloud-based platform. And in our experience, the standards creates a great starting point for ensuring a core set of services are enabled. But as you expand these services and as you look to the evolution of the marketplace, you need to have some level of remote access, remote management, and remote subscription service to meet the growing needs of small and large utilities, of business owners, of consumers, and of a broad range of other providers. The key is energy services will continue to evolve. I borrowed this slide, and I think this actually, the basis of this came from Siemens, from the eMeter group, but energy management services will continue to evolve. It's moving from awareness of energy to demand-side services to automated intelligent energy management platforms. And the devices that are going into homes and into buildings are the enablers of this, and they have to be interoperable, but the behavior can really be enabled through cloud-based offerings. And the cloud-based device management really helps this evolution, this spectrum of services to evolve, and it allows a broad range of service providers to be plugged in to enable these energy management offerings. So the key, these types of working groups are essential to establish standards, to establish cooperation between groups. The energy service providers and demand response providers are going to be varied, and if this industry is going to take off, we need to have a broad range of software services enabled. And there will likely be a number of different organizations across the globe that will deliver these services, from utilities to telecommunication providers to security providers. And a device cloud, a cloud-based management platform really enables these devices to be able to connect to a broad range of service providers. So ultimately, it's a subscription type of a model. So lifecycle subscription services greatly enhanced through robust cloud-based management capabilities. This is core. This has been, especially in the early stage of these technology developments, being able to take some of that functionality, remove it from the devices in the home, and be able to offer those through a cloud really maximizes the flexibility, it maximizes the roadmap, and it allows the industry to move forward much more quickly and effectively and in a much more open fashion. Apparently there was some slide issues there where the slides were not advancing. I apologize for that. But I will, to keep the webinar on track, I will pass control over to the next presenter, and I believe all the presentation materials are going to be made available to the attendees. So again, I apologize for the presenter slide advancement issues. So with that, and now I'm running into some challenges on.
Dave, I took care of it, and,
okay,
and that's right. We'll be sending the slides out to everybody who registered for the webinar.
Okay, thank you, Chris.
So hello. So I take the floor. So my name is Laurent Guise from Schneider Electric, where I'm the director for smart grid standardization. I have also many roles in standardization bodies, either at European level but also at international level within IDIS, where I'm member of, as you've seen, many groups. So the purpose of my presentation actually is a question to whom? A question to SEDC members. The purpose of my presentation is to ask whether there is a room for setting up demand response standardization guidelines, I would say, from the market. So why do I raise this question? I must say that, and we see it day after day, that standardization is absolutely not in a standard context, which means that the it is requested to get standardization for demand response, because everybody recognizes that it is absolutely a key for a successful deployment of demand response. However, there is a lot of immaturity, I would say. First, we know that the business models that will be used to support this demand response are not mature, and there is a lot of open questions regarding legislation and so on. This is on one side. And on the other side, we have market expectation, and then most of the stakeholders are currently requesting a minimum, what I call security on the perennity of the solutions they are going to select. In addition, we are in front of a technology, really, the foundation, the technology foundation, which is moving. So actually, as part of standardization bodies, we are in front of something which is not at all easy to standardize. So not mature requirement and not mature technology or moving technology, and a huge market pressure. So what could be the next step? So before going to ask my question, I just want to raise one point, is that there are currently many bodies. I just select one, and surely I forgot bodies that are currently either addressing or just feeding demand response standardization, but there are currently many. And one point which I think should be considered by all stakeholders is that having lack of standards is almost as bad as having conflicting standards, too many standards. In any case, both lacks or conflicting standards are leading to slowing down market ramping up. So it is absolutely not in the interest of the stakeholders to have to go into that situation. So that's why I'm currently opening a question to the stakeholders, to the members of SEDC. So why SEDC? Because I think SEDC has really a unique position regarding demand response. There are many very important stakeholders, and also SEDC has a wide variety of members. And we must not forget that standardization is stakeholders, which means that most of the standardization work is performed by the stakeholders. So my question here is to say, so is there a room for setting up, from the market point of view, some guidelines, some preferences that we could address to the standardization bodies? Typically, this is just an open proposal to claim the preference for international standards, to claim for a good coordination or a convergence, if I can dream, between, for example, North America, Europe, and Asia, about the importance of considering the existing, and so I mentioned OpenHAN, but this is not the only one, but at least to consider the existing and not to reinvent the wheel, and also to support, to be supported also as much as possible with some existing and stable technology. So I mentioned web services, but I could also have mentioned something else. The importance of going by step, which means that considering that the target is moving not to try to embrace everything and every type of use cases and so on and so on, so to be very, very pragmatic. And at the end, I would say to avoid what I call mushrooming standardization activity that will be in any case bad for all stakeholders. So this is my question that I'm currently raising here. Perhaps to summarize, I would say that the best maybe is the enemy of the good. And clearly, if SEDC members could claim for the best, I would support it. Well, that's all for what I expected to present it here. So I propose right now to give the floor to the next presenter.
Okay, Dave, you should have the floor.
Okay, can you see my screen?
Yes.
Yeah.
Very good. Hello, my name is Dave Harden, and I'm responsible for smart grid standards for Internoc. And I'd like to build upon Laurent's presentation a little bit. Demand response is becoming a high priority around the globe. And even though electrical systems and specific energy priorities vary greatly, demand response is a common denominator. This is starting to pull companies and organizations together as they realize that for solutions to become truly cost-effective, they need to be applied on an international basis. This requires the development of standards that promote global interoperability. As a result, several organizations have really stepped up to the challenge of coordinating and driving toward international smart grid standards. These include in the EU, CEN, the European Committee for Standardization, CEMELEC, the European Committee for Electrotechnical Standardization, and ETSI, the European Telecommunications Standards Institute. In the U.S., the National Institute of Standards and Technology, and the SGIP, the Smart Grid Interoperability Panel, which is a national, U.S. national public-private organization founded by NIST, are all heavily involved. But then, last but not least, is IEC, a very important international standards development organization. Given that there's so much diversity between and within nations, a major key to success is developing a common understanding of needs and wants and how these needs and wants should be structured. This falls within the scope of smart grid architecture, which is based on modeling techniques such as use cases. Once an understanding is achieved about what needs to be done, then of course discussions and convergence on how it should be done can follow suit. In the U.S., the SGIP Smart Grid Architecture Committee has been involved in developing an architectural framework for smart grid. And in the EU, CEN, CEMELEC, and ETSI have also been involved in developing an architectural framework. But these are not totally separate efforts. The EU, through the SG mandate M490, created the Smart Grid Coordination Group. This team commenced work on the Smart Grid Architecture Model by leveraging existing U.S. work, but looking at the problem through an EU lens. Without going into details, the Smart Grid Architecture Model extended the U.S. models with several important concepts. One being a 3D view of the model, and the other relating to an emphasis on distributed energy resources as a separate domain. There is very active and ongoing collaboration between the SGIP Smart Grid Architecture Committee and the EU Smart Grid Architecture Modeling team to align these models. Can we develop a truly unified high-level model? Well, we're not there yet, but progress is definitely being made. Let's drill specifically into some international DR standards. Laurent mentioned these, and he and I are both very active in these efforts. Last year, the IEC commissioned the Program Committee 118 to define the smart grid user interface. This user interface refers to electrical power user, not a graphical user interface for a computer. The PC 118, in turn, is divided into two closely related working groups. And the mission of PC 118 is to develop the definition and requirements for this user interface. Identify what is needed for architectural alignment. Identify gaps and overlaps in existing standards. Develop a standards roadmap and make recommendations for next steps. The recommendations developed will be fed into existing IEC committees for incorporation into existing or new demand response standards. The current schedule is for completion of the roadmap in mid-2013. As part of this process, the IEC team is evaluating the SGI PDR standards framework, which is shown right here. Let's take a quick look at it. I don't have a whole lot of time, and there's a lot of information on this slide. But in short, there are 7 major domains with standards for communications between the customer domain and the markets, operations, and service provider domains. 2 important standards are the Smart Energy Profile 2 for smart meters and OASIS Energy Interoperation, which gathers pieces from several existing information models, such as OASIS eMix for price and market signals, and from OASIS WS Calendar for schedule communication, the IEC SIM Common Information Model for power-related information elements, OpenADR as the base for the DR signal information elements, and the NASB energy usage information for consumption data. Inside the facility, the main energy information model under development is the ASHRAE 201P. That's the Facility Smart Grid Information Model. 201P is being targeted for implementation in various facility domain protocols such as MACnet. The customer domain is further decomposed into several subdomains: commercial buildings, industrial facilities, and homes. The standards listed in the framework were developed to enable energy management based on dynamic pricing, demand response, and energy efficiency. Other standards are being developed to support the managed charging of electric vehicles, integration of customer-sided distributed generation, and the integration of autonomous energy systems such as commercial and industrial microgrids. You'll also notice a little door in the diagram labeled ESI, Energy Services Interface. Think of the ESI as a logical gateway interconnecting the customer domain with external service providers. This slide shows service providers on the left and the customer facility on the right. Grid service providers interact with some gateway device that hosts the ESI, the logical ESI, such as a building energy management system or a thermostat or an appliance. And then inside the blue arrows are the main pieces of information that move between the grid service provider and the facility gateway. Let's see. There we go. I'm going through this information very fast, so you can take a look at the slides later. I mentioned these standards earlier, but I think it's worth looking at them in a little more detail to see how they fit together. Energy interoperations defines the information that is exchanged along with the services for coordination of energy supply, transport, and use between 2 parties. Energy Market Information Exchange, EMIX, defines a common price and product definition model. A calendar defines an information model for communicating schedules. And then OpenADR2 is a subset of these standards specifically for DR, venting, and pricing, along with a full communication stack that includes security and message transport. OpenADR2 is further decomposed into 3 profiles. A is for simple devices. B is for enhanced devices with energy feedback. And C is for wholesale market to aggregator communications. And that was a very, very quick, broad brush over a lot of information. Much work lies ahead, but we're on target to create a suite of global demand response standards within the next few years. Thank you very much.
Thank you, Dave. With that, I'd like to invite additional questions from the audience. We did get a question this is for Laurent, but if any of you could also jump in. And the question is, will the 61850 mandate across the IEC present challenges for demand response standards, or is it complementary to demand response standards?
Can you repeat? Sorry, I didn't catch.
Yeah, the question is whether the 61850 standard is complementary to or will be in conflict with demand response standards.
Oh, definitely complementary. So currently, for me, IEC 61850 has been designed mostly to vehicle technical data exchange for measurement, for retrieving, for remote control, and so on. So is very good at that. So in some cases, it can complement demand response, but it has not been designed at all to support a commercial transaction. No. The question potentially, and this is something that we need absolutely to consider, is the relationship, for example, between OpenHAN and ZIM, because the border is not so easy to define. So this is typically something that we have to address by sure.
Okay, and did any of the other panelists have any comments on 61850?
Yes, yes, this is Dave Harden. I'd like to just make a quick comment here, reinforcing what was just said. 61850 is a SCADA standard, and the OpenHAN is specifically designed as an interface to the customer domain. Having said that, there is definite overlap, and there will be work being done currently in the PC 118 IEC. Will address that issue in terms of making sure that the information models are coordinated between the standards. We want to be able to move information, from the customer domain up to service providers in a very clean fashion. We will be going through different transports at different times, different standards at different times, and so this is where the information models are extremely important, that as we move information from one point through one protocol and to another protocol, that the information is not distorted and it's not lost. And we want to make sure that we can provide a number of options. As far as distributed energy resources are concerned, those that are sitting in the distribution network, for instance, and near substations, will definitely be integrated using 61850 moving forward. Those that are sited behind a customer site may use 61850. They may use an industrial protocol, and so these are the different facets that we have to take into account.
Okay, we got another question, which is a question about which standards are being developed to connect appliances to the home area network interface, such as connecting a dishwasher to a meter.
Well, maybe because you are addressing the meter, you are addressing me. So, but we have here, from the meter side, we have a very pragmatic view, because a meter will not be installed because of the dishwasher. But with offering an interface or exchange of information to the dishwasher, we can add the value of the meter. But in order to add the value, the home automation application provider has to define what kind of data they want from the meter. And from the meter side, we are happy to provide any kind of data which is available in the meter. But we cannot drive home automation. Is not driven from the meter, but home automation is driven by the applications in the home. The meter can just support it. And therefore, I would say any standard is acceptable for the meter industry if the home automation industry can agree on one standard.
And
I think
Thomas,
beyond
do you
that,
have any?
Chris, to your point, you know, from OpenADR, OpenADE, Green Button, these are other initiatives from an application standpoint that I think can further allow, you know, application services to easily connect to a broad range of devices inside the home and inside the building. And so there's initiatives and standards both on the device side, as was discussed, and on the application side to help really drive interoperability and connectivity between these systems.
Okay, I've got a follow-up on that. A question specifically about Zigbee and the potential use of Zigbee for connecting to the meter, or rather than the meter, than to a home energy management gateway.
Well, again, from the meter's point of view, we will provide anything. We have projects where we provide Zigbee interfaces because there is an identified market for Zigbee, or the regulator has identified Zigbee as the standard interface to access home devices. That's perfect. The only thing we don't like too much for every project to provide a different interface. So we are happy to provide anything, and the higher the volume, the cheaper the interface. It's as simple as that.
Dave, maybe you can comment on the status of Zigbee?
Yes, well, I think, you know, so Zigbee has been widely adopted for HAN solutions to date. Smart Energy 1.1 and 1.2 are initiatives to really drive device interoperability from the metering standpoint and from a broad range of HAN devices for load control and demand response services. I think there's been continued cooperation to push forward the Smart Energy 2.0 initiative, and this is where, from our standpoint, you know, deploying devices today that can be remotely managed and upgraded to the Smart Energy 2.0 and future revisions, I think is really key, and has really allowed some of the early programs to move forward and to deploy these types of systems. And they will expand to include appliances and a broader range of devices. Most of it's been load control and thermostats today, but I think that the HANs will continue to expand over time. And the cooperation in developing these new standards, industry cooperation has been key to moving that forward.
Okay. Well, I see that we have one or two more questions, but we have run out of time, so we'll respond to those remaining questions by email. And I want to thank the panelists again for excellent presentations and providing some excellent information on this difficult subject, a complex subject in any case. And again, thank the audience for joining in today. Very much appreciate your interest in this subject, and certainly in the Smart Energy Demand Coalition. So with that, I'd like to thank everybody and wish everybody if you're in Europe, a good evening, or in the States, a good morning. So thank you very much.